Okay, let's discuss the ham radio power supply and the questions surrounding its components and operation. First, regarding the ceramic capacitor across the primary side of the transformer, its primary purpose is to suppress high-frequency noise generated by the transformer itself. Removing it could lead to increased noise in the power supply output, which could then interfere with radio communications. It could also potentially cause arcing or other damage to the transformer. Therefore, it's generally recommended to leave the ceramic capacitor in place. Now, concerning the issue of increasing the plate voltage in the tubes after the rectifier by changing the primary tap voltage, the problem you're encountering is that the rectifier output is not increasing linearly as expected when switching from 240 volts to 230 volts on the primary side. This nonlinear effect, where the output is much higher than anticipated, can be attributed to several possible causes. One possibility is that the diodes within the rectifier circuit are operating outside their ideal or specified forward bias region. In other words, they are not conducting electricity in a constant and expected manner. The high primary current at 230 volts may be exceeding the diode's current rating. This means the diodes are being pushed beyond their design limits in terms of the amount of current they can safely handle, and this excessive current can lead to unusual behavior or even damage. Another factor could be reverse leakage. The higher reverse voltage across the diodes might cause significant leakage current, reducing the output voltage in a way that does not match the linear expectation. In simpler terms, when the diodes are not supposed to be conducting, they might be leaking a small amount of current, which can affect the overall performance. In addition, there is also the possibility of diode failure. One or more of the diodes may be failing, resulting in rectification at a lower efficiency. If the diodes are not working as well as they should, the rectification process, which is converting alternating current to direct current, might become less effective. This would mean that the output voltage might be higher than expected due to irregularities in the rectification process. Here are some recommendations. 1. Leave the ceramic capacitor in place for noise suppression. 2. Check the diode ratings to ensure they are suitable for the current and voltage in the power supply. 3. Consider replacing the diodes with more robust or higher rated ones to handle the increased current and voltage. 4. Monitor the diode temperature during operation to prevent overheating. By considering these potential causes and recommendations, you can investigate further and diagnose the issue more accurately, leading to a solution for achieving the desired plate voltage increase.